Hey guys, as promised, I'm going to start going over Unit 6 review. Probably just do the first 7 questions in this video. So question 1, it asks, which of the following best describes the concept of distributed computing? And the answers are a network of autonomous computers that communicate with each other in order to achieve a goal, a single computer that manages all the computers in a network of autonomous computers that work independently of each other to achieve a goal, or a network of tightly monitored computers that work independently of each other to achieve a goal. So distributed computing, that's basically whenever you have a whole bunch of computers and they all are working together to do one thing. So your actual answer is this first one here, they communicate with each other to achieve a single goal. An example of that would be like the SETI project. So let's go to question 2. Which of the following is an example of a sensor network and its application? Select 2 answers. Doctors implant an automatic insulin pump into patients with diabetes. Okay. Or cameras with heat detection software are placed in the woods in order to monitor risk of a forest fire. Chiropractors use electric simulation machines which send electrical impulses from node to node on the human body. Or when a cell phone receives a phone call, a text message, or notification, it has the option to vibrate, ring, lighten up, etc. in order to alert the owner. Okay, so a sensor network. So a sensor network, a sensor would be like anything like any kind of cameras, like security cameras. It could be even like heat or smoke detectors that are hooked onto a network. So see this first one here, the doctor's implanting an automatic insulin pump, that would count as that. Also the cameras with heat detection software, that would also be an option. This is pretty much a dumb option right here. I mean, as not a smart or computer controlled. And then cell phones receiving phone call, that's not any kind of actual sensor network. So these are your answers for this one. Question 3, which of the following problems could cloud computing solve? Select 2 answers. Okay, a photographer has all of their photos stored on several different hard drives, but they're having an issue storing them in their small one-bedroom apartment. Okay, so cloud computing. So think Google Drive, right, or Microsoft OneDrive. Those are definitely examples of cloud computing, right? So storage out in the cloud. So this one is definitely an option. Then a group of students are trying to complete collaborative English project, but 2 of their group members cannot meet over the weekend to finish it in person. Okay. Next, the recording artist has created a remix of the favorite songs, but after releasing it, has been contacted by the original artist and asked to take it down because of copyright infringement. Okay. Well, that's definitely not anything to do with cloud computing. A football fan is trying to stream their favorite NFL teams online, but has poor connectivity. Okay, that really doesn't have anything with cloud computing. So cloud computing is going to require a good connection. So right there, they're saying that's a bad connection, and this is just getting kicked out of the internet. So that's definitely not an option. So that kind of leaves this guy here. So these are the options you need for number 3. Okay, so question 4. Which of the following would be legal use of digital media? You download a song from iTunes and sing it to the cloud. Okay, that's legal because you own it, right? You download an app on your smartphone, allows you to strip audio from YouTube music, and permanently keep that audio in your music collection. Oh, so that's not legal. You're not allowed. That's basically stealing, so that's definitely not legal. Number 3 here, you make an MP3 copy of a song because the CD you bought expressly permits you to do so, and then you put that copy on the internet using a file sharing network. Now, okay, so you buy a CD and you have music on the CD, so yes, you own that CD, but you do not own the redistribution rights, so that would be wrong. You cannot do that. Last option here, you have a computer with a CD burner. burn copies of music you download undesirable. Okay, so again, same kind of deal. You can't make copies and distribute it, even not for sale. You're not supposed to do that. That's against the rules. So first here, the iTunes, that's legal. You can do that. So question 5. An archaeologist is studying Native American ruins in the South American Southwest. He has recently found a previously unknown settlement, which is to share the find with his research partner who is off-site. Which of the following would be the best method of both documenting his discovery and allowing his research partner to participate and view the settlement in real time? Okay, so it says use a real-time conferencing application on a tablet to allow his research partner to see the site, record the conversation for later. Okay, that sounds like a really good option right there. Look at the other ones though. Use a digital camera to take pictures of the site, upload those pictures to a cloud server, and use notes to attach file. Well, that's an okay option, but this other one's definitely better. Using a digital sketch pad, sketch the artifacts that are found and send the sketches along with the notes. Okay, that would have worked great before we had cameras, but no, the first one is going to be by far the best option. Or call your research partner on a cell phone and give verbal descriptions. Okay, yeah, definitely this first one. That's your best bet for that one. Okay, so question 6. So which of the following would be the best way for researchers to collect data which could help them understand how a temporarily unavailable network connection affects connection speeds? And our options are developing a simulation of packets or simulation of packets of data traveling between computers on a network, developing a mathematical model for the impact of increased network speeds upon a web server, creating the software and hardware solution that ensures network connections are much less likely to fail, or sabotaging a major internet connection and asking the people to report connection speeds of various websites. Okay, it should be pretty obvious. You're not going to want to sabotage a major internet connection for a test, right? That would be bad. You would not do that. Could you create software and hardware solutions that ensure network connections are much less likely to fail? This is like opposite. We're wanting to figure out is it what happens to the data if a network connection is basically interrupted. So I made this little model here. So say we're at computer A here, and we're sending our data to computer B. This is our network, right? Each one of these circles are a node. So normally let's just say that normally the data travels this path here, right? So what happens if this node goes down? That means we can't go that way anymore. So what we'll have to do is now the data will have to go, say it'll go this way. All right. So what they're asking is, how can we figure out the best way, or how, if this node goes down, what's going to happen to our connection speed, right? So let's go back to the problems. So can you use a mathematical model to impact the increased network speed? Not really. That's not going to really help you too much with this, but you can make a simulation that would do exactly what I showed. Like say you build that simulation with all the nodes in it, and you break off one of those nodes and see how what kind of data speed is changes, from one of those nodes going down. So yeah, simulation is the way we would figure that out. Okay, so question 7. When a message is sent across the internet using TCP/IP protocol and is sent using network packets, which of the following does each network packet contain? It's like 2 answers. Spoiler alert is these 2. So first off, a network packet. In each packet, if you watch the videos, it'll say that there's a portion of that data is in every packet. And also in each one of those packets, it has to have routing data, so that way it knows how that packet can get to where it needs to go. So you do not have an entire message. It's only a small part of it. And then, an alternate destination. Yeah, that packet has a specific spot it's going, so there is no alternate destination. All right, so so that's questions 1 through 7. The next 7 we'll handle in the next video. So see you guys later.